Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. This is Greg Stumpf out in Norman, Oklahoma, with the Meteorological Development Lab Decision Support Branch. And this is our quarterly virtual laboratory project and community owners meeting for February. And you should see my agenda right now. We've got a number of things that we're going to chat about, a bunch of new stuff that's coming to the VLab since we met last November. Ken Sparrow is also going to be demoing some of these new things, and then we're going to look and listen to Pete Rohr as our spotlight person on the geostationary lightning mapper community spotlight. So as usual, we'll start things off with Steve Smith. And Steve, you are unmuted and you can go on.
Can you hear me, Greg?
Yes.
Great. Well, thanks, Greg, and welcome everyone to our first edition of the Project Community Owners meeting in calendar year 2019. So happy New Year, everyone. I want to remind everyone that the purpose of providing these meetings is the project and community owners, which you represent, are our biggest stakeholders in the VLab. We basically look to you to help us make it the best virtual lab that it can be. So I want to remind everyone that during these meetings, please feel free to ask questions at any time. Don't be shy. If you're not getting your questions, if you're not posing your questions, they're not getting answered, and you're not getting the benefit. So this meeting is for you, so take advantage of it. I want to thank again our VLab support staff who have been working very hard at addressing some of the items that you have requested either directly of us or through the VLab improvement team, and we're going to be seeing some of the fruit of that has been realized in the VLab over the last few months. Shortly, a lot of hard work goes into the planning and execution of these enhancements to make the VLab experience better and better. So last thing I want to say is we were lucky the VLab was up and running during the shutdown, and we did have users who were able to use it, and that was a good thing. So again, providing the benefit for those who were either in a working status at the time or some of the contract contingent throughout the NOAA that were continuing to work despite the government shutdowns. The VLab was up for that, so that was a good thing. So without further ado, I'll hand it back to you, Greg.
Okay, thanks, Steve. So we'll jump right into what's new in the VLab with Ken Sparrow. And Ken, you should be... I'm trying to unmute you. You may need to do it from your end. Yes. Okay, and I'll go ahead and make you the presenter. And take it away, Ken.
All right, great. Well, welcome. So we'll cover a number of items. That's what's new. The first thing is something that we just implemented this week. It's been a long time in coming, and that is that there is for external partners now, there's one single account that's used across all the VLab services. So when you guys as owners make a request for a partner account, for us internally, we only create the account, one account that's shared. That streamlines the process for the users because we don't have to send out two sets of credentials. They don't have to manage two sets of credentials. If they have to reset their password, and in fact, the very first thing that they get is an email telling them to set their password, they would just go to the VLCS and click on this Request External Partner Password Reset link that I'm highlighting right now, and then it would email them a link that they would be able to go to and set their initial password, and then step through the process as you normally do when you first log into VLab. So that's a positive benefit, and so that's something that's brand new. Other changes, let me go ahead and get rid of this, is that we have now, we've had for a long time public pages for each of the people within VLab, and so that's my dashboard, or I'm sorry, my profile, and so on my dashboard, these are private pages that are available for each individual. We haven't advertised these yet, but we're giving you a heads up, and I think we actually gave you a preview of this a couple months back. But the idea here is that these are pages that will be useful for you as an individual, and so it lists out the communities that you're a member of, any announcements that are pertain to you, all of your projects, if you have any projects that you're a member of within VLab, are listed on the right. And then if you have any issues that you've written up within Redmine, VLab's Redmine, or any that are assigned to you, those appear here as well. So you have access to all that. And then you can, of course, create personal bookmarks that you could get to. There's also social connections component of it, and the connections are, we're calling them associates. And basically you can go in, and the advantage here is that if there are other people within VLab and you want to kind of see what they're up to, you can add them as an associate, and the associate would then, you'd see their activity. It's a similar concept to Facebook. It was Liferay, which is a product that we're using for VLCS. It's our kind of take on it. And we're working on strong use cases for it, but this is something that's there now and is available to use. And we will advertise it more widely as we come up with better use cases for it. But so that's that. And then you can, of course, write your own blogs as well. So, and then people would be able to, subscribe to those and get those blogs too. So that's my dashboard update. We do have some changes coming for Redmine. There are product upgrades there, and so there's some new features that'll be coming, as well as addressing some deficiencies. Redmine will be looking for that. And then in addition to that, just a heads up that we're currently working on restructuring the VLab community page. So what do I mean by that? What I mean is that a couple months ago, we rolled out, thanks to, in large part, to TauFam, the reorganization of the landing page, this page here. But what we're talking about is the community itself has grown quite organically over time. And so we're looking at improving the layout of the pages, what's on those pages. So we've already done on that default page that you land on, but there will be a refactoring coming in the next month, I would guess. We're doing an internal review this Friday with our team, and then we'll get it out there at some point in the next couple of weeks. So that's that. And then do you want me to transition into the demos now, Greg?
Yeah, that'd be fine.
Okay. All right. So now I'll show you some other things some demos. And these are things that aren't quite there yet, but we're close. So one of the items is that we've streamlined the way in which you request projects, communities, and repositories. And so let me show you that. So under the request new resource, this is in our dev system, so it isn't in production yet, but we'll be getting this out pretty soon, I would expect by next week. So it's been fully tested. So basically there's one request form, and just so everyone remembers, when someone needs a new community, you can come in here, click on new community request, and it has a specific form for that. And it's here. And then under development services, there's a separate one for projects and repos. So what we've done is we've consolidated that. And so each of those links will then take you to this particular form, and you can come in here and say, okay, well, I want a community, and I also want a project, or you can do them independently. And so there's a list of questions that you're used to already answering that are in here. We refine them a little bit more. You'll notice that the community owner organization is listed now, and that highlights something that I'm going to show you in a minute that I've already demonstrated before, but it'll just be a review. And then there's also the code repository. So this form will be one place to go. I think it looks better, and it also adds additional information. So for example, if you need continuous integration, Jenkins, we ask a number of questions through the form now that weren't there before. So these have all been refined. So that'll be out there shortly. And so that anyone requesting new VLab resources will go to this new form, with the exception of the external partner. And that was different enough that we didn't combine it with this form. So that'll still be there for people. So that's about to be launched. We're, in addition to working on the Redmine upgrade, we're also working on an upgrade to Garrett. We're, I believe, on version 2.13.4 right now. There's a 2.16.3, I believe, is out there, or maybe 4 now. I'll have to confirm. But I've got a couple of our engineers are actively working on it. And so Garrett has, there are significant improvements to the interface. They've changed the UI, and we're also taking this opportunity. So we've got some screen captures here for you. And so you'll notice now along the top, we're doing some theming of it, similar to what we've done within the other components of VLab. So we have our logo on there. We're using the color scheme similar to the others. And then also we have the components drop down that'll allow you to get to the other services for VLab. And so that's the main difference. There also, close that one, bring up the other, are some changes in the way it looks. The developers of Garrett itself, it's a Google developed product. And they have made significant changes to the interface, hopefully for the better. We'll be previewing this to our users before it goes live, giving people an opportunity to see it before the change comes, because we know that this is very actively used by our the code developers using VLab. So anyway, that's another view, and then we've got one more. Let me pull that up. That was here. So you can see here, these are just 3 different views that are being that we're showing in terms of you can still get to the same functionality to be able to download, do reviews, see the projects, change access permissions, things like that. So, and this is an example here where you'll be able to get to those drop down the other VLab components. So Garrett, new interface upgrades, that's coming. Another thing that's been actively worked over the last couple months is the Ideas Marketplace. Ideas Marketplace was it is a tool that was requested by Eastern Region within the National Weather Service, and we developed a custom portlet to meet their needs. And so if we come out here, I'll just go to the Ideas Marketplace, give you a sense. And so this is the current version of the Ideas Marketplace. You can see this tab type view, or card type view, I should say. And this is something that we thought could be improved upon. And so there's been some energy put in place, mostly by Mike Giebler, one of our developers who developed the portlet. So he's been refactoring and improving upon it with the help of Tao Pham, who's our UI specialist. And so I'll show you the example here now. And so, these, we're using the cards. You can still, sort it. It allows for different fields to be able to sort. You can click on them, and you can upload an image with your idea, and that would appear. You can rate it and things like that. You can do all these things otherwise, but I think from a look and feel perspective, it's much nicer. And some of the other things we've done with it is that we've added tag and category navigation. So, for example, if you wanted to go in and if you flag the idea as being weather service specific, you can click on NWS and then get a listing of all the ideas that are associated with the weather service. Likewise, if you use tags with the ideas, and this is size based upon the number of tags using it, you can then filter based upon clicking on that. And so, anyway, that's being reviewed by the stakeholders, Brian Moretsky out in the Eastern region, and he'll have an opportunity. And as long as everything's working the way we expect it to, we'll get this rolled out to production. And this is something that could be leveraged within your community too. So if you have a need to be able to collect ideas from your users, you could add this portlet to your community and then take advantage of it, and allows for the ratings. You can also have discussions based upon the ideas as well. So if you click on an idea, it'll actually create that, go into the forum for it. So I'm going to go ahead, and lastly, let's talk about the communities and the things that we've done there. So let's come back over here to production, and if we go back to homepage, and so under communities, I just wanted to take this opportunity to remind everyone that you can now sort the communities based upon the line office. So if I wanted to see the listing of weather service communities that are tagged with that, you can do that, and those appear here. You can see up here that it's been filtered by NWS, and those are there. If I wanted to go to OAR, I can switch that to OAR and get the listing there. It applies to both the My Communities page as well as the available communities. So if you're trying to find out or do some investigation and you want to join some new communities, you can come into here and click on these to be able to filter that. So that's, I think, quite useful. Also, be aware that, I think we highlighted this before too, but just as a reminder, the activity level associated with the communities is being included now as well. And the default ordering is based upon that activity level. And if you hover over these little icons, it'll then give you some indication of where that activity level is coming in. So in this case, most of the activity was, or all the activity was in the documents. So they've obviously been very active in the documents area. Whereas this one too, let me see if I can find an example. So this one here, you can see the Boulder model. The activity is within the last 90 days has been within the wiki. So 67 updates to the wiki over the last 90 days. So, so this gives you a good way of getting a sense for, is this a community very active? And if so, where is, how is it active? So you can see, so I think now that we've made these enhancements between the member count, the site owners, and the activity level, and then also given the ability to filter based upon the line office, I think those are powerful tools to be able to dive in more easily and figure things out before actually joining a community. So those are my updates for today. Are there any questions for me?
If you have any questions, you can use the raise your hand feature in the dashboard, the GoToMeeting dashboard, or just use the question feature. Any questions for what Ken has just talked about? Okay. Well, you have a chance to ask questions again at the end of this meeting. So anyway, thanks, Ken, for the informative updates. I'm going to go ahead and take control back. And just wanted to also remind everyone that if you have any suggestions or anything like that to improve the VLab, if you go under, let me make sure you're seeing this. Yeah. If you go under the help button here in the upper right, it'll take you to a page. And here on the right is the user feedback area where you can submit suggestions to the virtual lab improvement team, the VIT, or send feedbacks to the support team. So, and as usual, if you have any day-to-day issues with VLab, you need some help with support, there's the vlab.admin@noaa.gov email address that you can use. So, okay, just make sure no one else has got their hand raised, and we'll go ahead and we're going to now hear from Pete Rohr, who's going to talk about the geostationary lightning mapper community. So I'm going to go ahead and change the presenter to Pete, and you're unmuted, and you can go ahead.
Okay, thanks, Greg. As Greg mentioned, I'm Pete Rohr from the Science and Technology Integration Office in Silver Spring, Maryland, and I've been pretty involved with the GLM basically from the onset of the requirements, definitions, and all the technical development going way back to the days of the ER2 overflight back in the 70s, and of course the space shuttle missions and the polar orbiting satellites TRIM and LIS during the 90s and early 2000s. So I'll go ahead here. Basically, I'm going to talk about the geostationary lightning mapper, basically the technical aspects of it. It's much different than ground-based systems in terms of how it detects lightning, and I'll go into that. And then I'll also talk about some of the National Weather Service products that are being developed that are available right now, and those that are in the bin, and how those products are starting to flow and how they look on AWS. So basically, the geostationary lightning mapper provides continuous total lightning measurements. It has, since GO 16 went up before as GOES are, covers from 54 north to 54 south, so it goes deep into the southern hemisphere, and across the oceans within the range east-west of the GLM field of view for GO 16 and what will be GO 17 fairly soon. It detects total lightning, but it does not distinguish between intercloud and cloud-to-ground lightning. That's something to remind everyone about. We need the ground-based systems to identify what are the cloud-to-ground flashes from the flashes that are in the field of data. The GOES team has worked alongside the instrument vendor to reach beta by June 2017 after GO 16 is launched. We have provisional January 2018, and I'll go into the products that are currently available, and then full operating status November 2018. GLM detects electrically active storms and aerial lightning extending via a really large frontal system. This is from last October, and storm system showing the lightning activity with the yellow flashes going across the screen, across the central plains, and then you see another storm developing down in the southeast. Basically, it allows the forecasters to track embedded convective cells, identify strengthening and weakening, and I'll go and look a bit about that, how it shows the weakening storms and any regeneration that the cloud-to-ground lightning networks may not show. Monitors convective mode and storm evolution, characterizes storms as they transition offshore, and very importantly, it gains insights into tropical cyclone intensity changes that we could not see with the ground-based systems very well before. So basically, GLM creates the background images every 2.5 minutes. And I want to remind everyone, I think Scott Orlowski's on the line too, but Scott is the chairman of the, and I'll go into this later in the briefing, but he's the chair of the implementation group for the GLM product. And he'll be helping me answering any questions toward the end of the briefing. The text changes in brightness relative to the background every 2 milliseconds. And what's incredible during the daytime is that it can identify lightning flashes against a very bright cloud background. And this is something, the technology has been developed over 30, 40 years and has been perfected with the line of oxygen, the emission line of oxygen, O2, and also some spectral, spatial, and temporal filtering to actually detect, as you see on the right, that lightning flash amongst the bright clouds. Of course, during the nighttime, it's a lot easier. So limited pixels are termed GLM events, and I will go into how these events are organized into flashes fairly soon. The focus determine the likelihood that the events are, in fact, real lightning. And the false events identifier, it's usually about 5%. It's pretty good for the GLM itself. And then there's a lightning cluster filter algorithm that combines the events into groups and then into flashes, as I'll show on the next slide. First, we have the events, and this is basically the skeleton of the GLM data, showing the occurrence. It's on occurrence of a single pixel, and the GLM, the spatial resolution is down to about 8 kilometers. So you're basically working with 8 kilometer definition, trying to find multiple events, and they exceed the detection threshold of a 1-2 millisecond time frame. Then the events, one or more of which are grouped into groups, and these GLM events are observed in adjacent neighboring diagonal pixels. And then furthermore, those groups are identified in a combination. I'll show a different slide that shows this a little bit better. They're showed into a flash that's separated by less than 330 milliseconds and separated by 16.5 kilometers. So, of course, the GLM flash waves, being total lightning, not cloud ground lightning, are most closely identified to the updraft and storm evolution. So, for the event, group, and flash locations, and I told you I would show better definitions, it's purely something that Scott came up with. First, you identify the events where they're shown on the right-hand side. And those events are grouped into groups. You see 2 groups in this particular type of event. And then those 2 groups are further identified through centroids to find where the actual flash is occurring. And the flash location, defined as the X on this particular slide, represents the radiance contributions from all events in both groups and may not always fall along the relatively narrow lightning channel. And remember, these lightning channels, they can stretch for miles to perhaps 40 or 50 miles across the cloud systems. It's very phenomenal what this can identify. So the GLM maps the extent of the cloud illuminated by the individual flashes. And despite a relatively coarse spatial resolution, I mentioned that 8 kilometer resolution, the GLM can provide rapid temporal updates, allowing it to map the flash structure as you see on the right. The groups are used to create flash skeletons, and the optical lightning observations provide helpful insights into the flash structure. And I'll go into this. This is something we're looking into, the actual radiance of, this is an optical system. Seeing the radiance of the flash may help us in the future in terms of combining with the radar data to really see what's going on the top of the storm structure. And it can be used to make inferences regarding lightning physics and storm structure. So you're observing individual flashes, clearly illustrating that GLM is an imager rather than a detector, as has been defined in the past over the course of the ground systems. The lightning composition and the time evolution provides insights into convective mode and structure, and we are all working as a team, the GLM team, to quantify this information, develop products that will aid forecasting. So initial GLM distributions, we've had a chance over a one-year time frame from about December 2017 to the present to see what the lightning distributions are across the GOES 16 field of view. Basically seeing the land distribution on the far left to see around this time of year, December, January, February. Of course, most of the activities down in the South American region and over the oceans in the ITCZ. And then that increases, and we're getting excited about this, especially with this oncoming storm season, spring and summer, of seeing how the GLM is showing the activity over the United States up into Canada, and of course into the June, July, August summertime frame. That's when you start seeing the full advantage of the GLM, especially in terms of tropical cyclones and whatnot. Another advantage of the GLM is showing diurnal cycles, showing the diurnal cycles of, for example, this can be done with the place that has the most lightning activity of any place on Earth, and that's Lake Maracaibo down in Venezuela. And there's an ability of the GLM to show lightning distributions at every location within its near hemispheric field of view. And again, I mentioned that before. It goes from 54 north down to 54 south, and it's over a very wide expanse of the Western Hemisphere. The LAS could require up to 35 years to sample the diurnal cycle for the equivalent of just 257 days that have been studied here. And again, you see off to the far right, I'll go on to the next slide, there is not only a max, as you would expect, in the afternoon to early evening hours, but you also have maxes detected around the nocturnal time frame, around 2 o'clock in the morning. So there are some things that we'll be able to see with the GLM that we had not seen before on the diurnal basis. So the GLM flash area duration follows similar diurnal trends. And it's a notable exception that appeared near the solar noon over both lake and land. This is for the case of Maracaibo. And then there's a secondary lightning frequency that spikes result from longer duration flashes, indicating possible effects from sun glint and blooming. Again, we're looking into that. So, getting into the meat of the matter, talking about how is the GLM going to be used in the National Weather Service, as well as NOAA. GLM observations fundamentally differ from the ground-based lightning data, most familiar to forecasters. Of course, we have the VLab cloud-to-ground lightning network that's been around for many, many decades, since the early 90s. And we also have the Earth Network's total lightning network that covers CONUS, and we do have some lightning available in Hawaii and Alaska. But that's total lightning. So we're trying to compare the total lightning from the GLM to the ground-based networks, which are based on radio frequency data. Of course, the GLM is optical. Initial demonstrations revealed that the early GLM tools were not well suited for real GLM data. So there had to be some modifications done with some of the AWIPS visualizations of how AWIPS was able to handle the GLM data. It was a different beast than the ground-based DISOL and Earth Networks data. So this motivated an intensive effort to develop a new suite of gridded GLM products tailored to National Weather Service operations. So now I'm going to go into a briefing that Scott gave back in Huntsville, and I added a few more slides to this. We basically talk about the implementation team, some of the test bed activities, how we're rolling out the data. That's basically the general gist of the outline. So the implementation team consists of quite a few folks that have been involved with this data even before the GLM went into orbit. Has been involved with the lightning mapping array and also with TRIM and LIS data back into the mid-90s. So they've been this development of products has been going on for quite a while, and preparation has been going on for quite a while for the GLM before it went up. So we have Scott Berlowski, who's from NEDS STAR. He's the working group lead. We have Kristen Calhoun and Tiffany Meyer, who are from the NSSL. We also have university folks that are very much involved, including Eric Bruni, and contributed greatly from Texas Tech. Of course, NASA Sport, Huntsville, has been very much involved for quite a few decades with this type of data. And then we have folks that are actually working with the data, processing the data, and making sure the data gets into AWITS quickly and efficiently. And those folks are mentioned toward the bottom of the slide, from observation, central processing, and SPI. Currently fielded GLN products in AWITS 2 include the one main one that has been developed and perfected over the last year is called the flash extent density, and I'll show some of those imagery from that particular product over CONUS. Essentially derived from GLN L2, the mention from the event, group, and flash data that we have. We have 1 and 5 minute grids, which I'll show on an AWITS map pretty soon. And then there's the IOC product was only, as I mentioned before, it's only the first step. We've got quite a few products that we're looking at and trying to work with the forecasters to integrate into operations over the next 5 to 10 years. So the fielded AWITS 2 baseline goes our plug-in handles and just in display GLN product. And the CONUS-wide rollout of FED occurred in summer 2018. And there were 21 NWS field sites involved in this particular rollout, looking at the products, making recommendations on how they look before they were seen by other forecasters. So the flash extent density grids are produced on the Aviation Weather Center ISAT-SS, which stands for the Integrated Dissemination Program Satellite Support Subsystem, and for distribution via the terrestrial LDM to NWS, WFOs, and river forecast centers. Eric Bruni was involved in the Python package for this particular process, and these compute the 1 minute flash extent density grids that are currently being used. If a flash has multiple events take place on a single pixel, its FED's contribution is equivalent to 1. So the ISAT-SS points into GLN grids generate minute-by-minute FED fields and also process them into 5-minute arrays. And then of course, this is 8-kilometer resolution, as I mentioned before. And prior to the FED grid generation, another ISAT-SS application uses a further image center technique to filter any given 20-second input L3 plus file from these multiple events. So how do we do the pixel geometry and location accuracy? Basically, GLN is a variable pitch CCD array with 56 subarrays and 1372 by 1300 pixels. This is imagery not too different from what we've seen from the Space Shuttle on the trimmed list. So we're pretty much familiar with what to expect. The variable pitch reduces the growth of the GLN pixel footprints away from nadir. Of course, users are looking, this is the same thing with the ABI product. If you look farther away from nadir, we have to make the adjustments for what the satellite is seeing and what we actually are seeing at the above the ground. So the gridded GLN products have a similar parallax effect to the ABI, and the parallax results in the gridded GLN products appearing shifted away from nadir, so there's some processing to counteract that parallax. So this parallax is shown in the next slide, which results in the gridded GLN products appearing shifted away from nadir. Of course, this gets worse and worse as if the satellite's over the longitude along Florida toward the Bahamas, then of course that parallax will get worse toward the north and west. This is something we're working on because it is a concern to the forecasters because the Earth networks data does have some resolution problems in the northern plains and the northwest U.S. as well. So this is what it looks like in AWITS. Basically, 1 minute GLN FED with 1 minute mesoscale ABI visible imagery up in the top of the slide. You can see the GLM data being processed across the Nebraska into Iowa. And then this illustrates the convective processes on various scales and over various time frames. Against brightness temperatures, IR brightness temperatures, you can also see this, the incredible GLN data against the IR field. And of course, the flashes are easier to detect and appear larger on the nighttime imagery. Additional GLM products are being evaluated for future AWIPS development, and they include the average flash area, AFA, and then total optical energy, something I referred to before, that will complement the FEV to maximize the insights provided by GLM. Each of the gridded products can be applied to similar forecast challenges, with certain products better suited to certain applications. And they also provide a context for understanding GLM data quality and the subtleties of space-based optical lightning rate observations as compared to the radio frequency observations that we're so used to. So the AFA basically shows an average area of all flashes coincident with each 2 by 2 kilometer grid cell during a specific time period. Units of kilometers squared, with values ranging from a minimum 1 pixel or 64 kilometers squared to several thousand kilometers squared for regions with extensive stratiform flashes. As I mentioned before, these can stretch for many, many miles, sometimes 40 or 50. And then a TOE in units of ferrojoules, with the decimal values for the dimmest flashes, more than 1,000 ferrojoules for the regions with the many white flashes. And I'll go into the advantages of those two. So bright regions, as you see on the pictures toward the right, the bright regions in the TOA indicate the most energetic convective pores and the lightning channels within the extensive flashes. And the AFA reveals small flashes and new intense convection, and then the larger flashes in stratiform anvil regions, and interestingly enough, and of course, the decaying type storms. Primary TOA applications directly represent optical observations, identify strengthening and weakening storms, and the AFA diagnoses CI and storm growth and observe the aerial lightning extent, and of course, storm evolution. And you can see some of the really good imagery toward the right. So diagnosing convective initiation and storm growth, and I'll show some of these products in the future. Some are related to Tallahassee, I believe. But they detect, monitor the thunderstorms where the AFA color map accentuates the small flashes to highlight the earliest flashes in pre-convective scenes. And then it provides a visual cue to help us quantify the growth rate of individual storm cells, which can be very important forecasters on a small time scale. They also differentiate the anvil stratiform flashes from newly developing convection, which can help out when we have multiple storm cells at one time along a cold front. Flashes often travel long distances, connecting to remnants of earlier convection. The AFA helps to identify where the flashes are actually coming from. And the new storm cores are often first apparent in the AFA and the TOE products. They also monitor storm mode and evolution, as you can see in the lower right. AFA on the TOE help to confirm false events as well as side and low cloud illumination. Some small flashes on cloud edges result in light escaping from below and just exceeding the detection threshold. The GLM level 2 data, again, as I mentioned before, includes the events as the baseline going to groups and then flashes, are produced as points, resulting, and you can see in the video toward the right over Florida, resulting in the loss of information concerning the spatial extent. The new gridded GLM product restores and disseminates the spatial footprint information while greatly reducing the file size, which is important when it's included in these massive satellite files. Gridded GLM products involve re-navigating the GLM event to the 2 by 2 kilometer advanced baseline imager, and this helps with matching to both visible and IR and all the other channels that we have on the ADI. So the corner point lookup table is used to recreate the event polygon from L2 points. Parent-child relationships are used to combine the event polygons into group and flash polygons. And then these polygons are subdivided at the flash group and event levels by slicing them with the ABI fixed grid. And then the next step, accumulate some weights to slice polygons of the flash group and event levels to create the gridded products that the forecasters see. So many years of research and operational LNA demonstrations that I referred to before have shown the FED to be the preferred total lightning product. And the FED that's portrayed in a single product, the quantity and the extent of the GLM flashes and events. So the GLM products were demonstrated and evaluated at the hazardous weather test bed in the spring of last year, just before the broader NWS rollout. The forecasters were pretty excited what they saw. Some examples in the following slides show something from the convective evolution of rapid storm development, where the AWETS display is showing the FED, average flash area, and the COE, along with ABI data. And the forecasters at HWT found that gridded products useful in terms of diagnosing both the development and decay of convective storms during ongoing severe events. It's also used for lightning safety and aviation application. I know very much of interest to folks like Dennis Atkinson, who I know is on the line, in terms of the products supporting Aviation Weather Center and CWSUs. I've seen some examples before the GLM went up of what Earth Network's total lightning data was showing. It's very exciting how the GLM can help out with mapping lightning in terms of where planes can come into corridors into airports, especially during the very busy airports of Atlanta and Chicago. So the GLM field-wide rollout, the final stages of the FE development in summer 2018. As I mentioned before, we had about 12 sites involved in the beta, and we had a few more sites involved in the overall testing. I got feedback from the extended evaluation sites, functional performance evaluation testing of the GLM working group, and then we used the RedCat package manager to configure for the information for the CONUS and NWS sites. This was done back last summer. And then there was a lot of training and outreach. The website, and I referred back to this at the last slide, but the website has that information that can help out with forecasting. There's been a lot of concentration on the training for this particular data. This is an example of some of the training orientation materials with the GLM data, including the GLM gridded products, the coming AFA and POE, overall GLM applications. It basically goes into we have a quick guide that was developed with the help of the Lightning Working Group, and there's also the virtual lab webpage. So some of the, this is what it would look like in the AWETS 2 cave environment, that basically go into GOES East, GOES 17, choose the GLM products. There's 6 subset regions, 1 minute versus 5 minute, and then you can find the flash extent density for certain time frames, certain areas of the country. So the initial GLM products provide forecasters a very new perspective and exciting perspective on lightning activity. For example, this particular storm complex over for Huntsville. Storms approaching Huntsville International Airport when the flex extent density was overlaid on reflectivity from MRMS and also combined with the MLDN from VISOA. So this helped the forecasters with the airport weather warning over a very short time frame, and the NLDN started showing the active lightning approaching the airport, and the GLM helped provide the insight. I mentioned the insight. The GLM, of course, the NLDN is used as the main operational tool in terms of lightning activity. The GLM is providing the insight with the NLDN with being the primary lightning data used for this particular event. What happened was that the GLM flash extent density started to change later in the event, and the storms had pushed well east. The convection started to weaken, lightning activity decreased. However, the GLM played a significant role in identifying the long flashes in the stratiform region, something that the ground-based systems have not been able to do in the past. And that showed that lightning activity continuing near the airport, and it illustrated that the threat was still there. Another example is with Tallahassee. You see over a very short time frame, over 1 hour, you can see the lightning activity mainly off to the west. And it was thought by 2330 that this event was pretty much over. The lightning activity started to develop over toward the right-hand side of the region. And the forecasters had to be very careful in terms of watching this. And they had to reissue a special weather statement based on the regenerated lightning activity that was showing to intensify toward the last half hour of that time period. So NWS forecasters are continually sharing feedback, and these folks are involved in the GLM testing team. They're also involved with the lightning working group, and they will continue to provide feedback to help drive GLM innovation and exploitation. So the next steps for the GLM implementation across NWS, I mentioned the FED product generation. We're also looking at the assessment of standard evaluation products and begin the migration of any mature products, so since I mentioned the AFA and the TOE, and explore and evaluate additional GLM-derived products in the future, and extend geographic coverage of the existing GLM products. So we're going to augment the NWS forecast systems for maturing GLM products. The rollout of Goal 17, which is ongoing, and other products via similar migration for the Go 16. So we have a footprint for how to do the Go 17 based on what happened with Go 16. And then suggestions came up from the National Weather Service in terms of how to improve the products for GLM, and that seeking to continue mitigation of blooming artifacts associated with anything related to solar intrusion and sun glint, and also the computational load of the NWS side FED grid generation. Areas for joint exploration. This is a combination of NESDIS and NWS. What we're looking into is the further investigation of the methods for conveying product quality, and a continued exploration and refinement of approaching for addressing things like geolocation and positioning of GLM products. So this is an overall summary of the NWS feedback, basically talking about the FED product and how it is being implemented, and that activity is being looked at and improved as we speak. So the path forward is optimizing the GLM use in AWIPS and continuing to do that in comparison definitely with API, making sure that the resolutions are intact between the two entities. Leverage goes our science funds to accomplish the first year and compare it with, we're also working with the vendors to compare ground-based lightning data with the GLM. And that concludes the overall briefing, and these are the locations of the GLM data and training guides for the virtual lab. And at this time, welcome any questions.
Pete, this is Greg. Could you go ahead and show us a little bit of the GLM community on the VLab and give us a little rundown on how the virtual lab has helped with regard to this project?
Okay. Okay, so this is the basic overall page. that Greg was referring to. This is the overall welcome to the GOES Lightning Mapper virtual community. As I mentioned before, there are the available archive grids for FED on that web link toward the middle of the page. There's some sample desktop backgrounds for some of the storms that have been looked at, such as Maria and Harvey, and also the data I mentioned for Lake Maracaibo. And the real-time imagery is available at those web links that are toward the bottom. In terms of the training materials, those are in the next link over to the right. And as I mentioned before, there's a lot of training products that have been and documents that have been developed for the GLM. And I welcome folks to look at these and ask Scott and myself any questions that you may have with these particular training sources. We also have a status button that basically shows the daily GLM status reports. And there's some information, I believe, on what's happening with development of the GOES 17 products, as well as what's going on with the GOES 16. Some of the products are labeled here on this particular link on the VLab. It includes a description of some of the GLM gridded products and talks about what events and groups and flashes are in case you have more questions about that. There's also a link over here on the implementation team and what has been going on with that. And we also have some imagery, most of which has been worked between Scott Rodlowski and the folks down at the NASA Huntsville. So again, I welcome any questions, and so does Scott, regarding the GLM, not only during this time, but also in the future.
Thanks, Peter. This is a very extensive VLab community, very well organized and thought out, and one of the highlights of the communities that are out there. So, folks, if you have questions, use the raise your hand feature. I see Ken Johnson has his hand raised, so you're unmuted. Go ahead, Ken.
Hi. Yeah, thanks for the presentation, rather comprehensive. I guess my question might be more for the VLab folks than for, because of, I'm looking at the, actually earlier today I was out in the community there, and on the overview page that you have up there over on the right, you've got some documents listed there, and I was trying to get at the very first one there, the Geophysical Research Letters document, and I couldn't do it. I clicked on it and it just came up. I couldn't get anything the size that I could read.
Yeah, it seems like I'm having some issues with that as well. Perhaps Ken could chime in. Ken Sparrow, are you there? Here we go.
Yeah, I'm here. I was trying to get unmuted. We'll take a look. I'm looking at it right now.
Okay, yeah, I appreciate it if you could. But otherwise, it looks like a really comprehensive community and fairly well laid out.
Definitely very well done. Let's see, we have a question from Scott Rodlowski. I just went ahead and unmuted you. Do you want to just go ahead and speak?
Yeah, I'm not sure. I could definitely benefit from closer collaborations with folks who know the VLab better than I. But I just tried to unlock the document. I'm not sure if maybe when I uploaded it, I had some permissions that I shouldn't have. And that might have had something to do with it.
Okay. Any other questions? Okay, Pete, very well done. Thank you very much. We're at the top of the hour now, and we'll go ahead and conclude. Well, before we conclude, we do have a roundtable opportunity as well. So any other questions from anybody else regarding anything having to do with the VLab before we sign off for today? I'll be looking for raised hands or questions. Hey, Sheila, you're unmuted. Go ahead.
Can you hear me?
Yes.
Okay, great. I just have like a general question in regards to email marketing and whether the VLab has a capability of integrating with emails that we may be sending out to forecasters or other community members, or if that's an option that can be looked into, or is that something that I'm talking more of, just email marketing, different open source platforms. So is that something that the team has the capability to do and LifeRay does, or is that it can't connect at all?
There are some, this is Ken, so there are some portlets that we have not rolled out that do integrate email capabilities, but I don't think that they're focused on campaigns. I guess, we've been talking offline, but we should talk further to see what exactly you're trying to accomplish, because I know that they do have some things that they've developed that are like more campaign oriented in terms of, because LifeRay is used, of course, as a commercial, or not, as like a product type intranet as well, where products are displayed and sold and things like that. So I know that they've developed tools, where they're trying to see the effectiveness of, pushing certain products and things like that. So I don't know if those might be applicable. In this case, we haven't really seen a need for those within VLab thus far, but this may be something, maybe. So we should probably talk offline.
Okay, thank you.
Sure.
This is Steve Smith. I just wanted to also chime in and back to Pete Rohr's talk, a really excellent overview of the GLM and the community that's being used to promote this effort. And it's a really good example of the type of corporate information that we hope to capture in the VLab for posterity. We know a lot of these projects are bigger than any one individual and sometimes bigger than people's careers. We don't want to lose the information when people move on to other things. So it's another important thing to keep in mind in considering VLab usage is to keep those corporate documents and so forth in a place where others can access it and in the future, so that this information isn't lost or mislaid with time. So thanks again to Pete for that really excellent overview.
Okay. Any other questions from anybody else? We're in the roundtable section, so anything having to do with VLab. All right, let's go ahead and call this the end of the meeting. Just want to remind everyone that the next meeting is scheduled for May 7th. It'll be a little earlier in the day, 1 o'clock Eastern Daylight Time. And also, this meeting has been recorded, and as soon as we process that recording and upload it onto YouTube, I will send out an email showing everyone where that is and how to access all the recordings from previous VLab Owners meetings. So, again, I would like to thank both Ken and Pete for their presentations today, and we will be meeting again in 3 months. Thank you very much, everyone.